Hi everyone, welcome back to this channel. This quick video I'm going to show you how can we use the spectrum view in channel scanning mode to do a simple debugging, especially when you try to measure a signal that's close to the noise floor but you're not seeing on the bar chart. So for example, I have a signal that's transmitting at 1 gigahertz. It's an FM radio signal. Frequency deviation is 28 kilohertz. And the transmitting power is roughly at minus 80 dBm. As you can see, this is the view when you turn on to channel scanner. So how do we get there is go to mode and just look for channel scanner. And once you click that, this is the first interface that you're seeing. I have explained more in the other video on channel scanner, so you can actually look through that again if you're interested. But in this video, I will just focus more on how to use the spectrum view to debug. So let's set the scanning channel first. Let's change the edit range. Instead of 5 channels, we change it to 1 channel. And I know the transmitter transmitting at 1 gigahertz. And it's a conducted test. It's connecting from my transmitter to FieldFox directly. So just to recap, this center frequency step size is used when you have multiple channels and automatically fill up. For example, if you have 2 channels here, you see what I mean. So the first channel is 1 gig, the other one is 1.002 gig, which is a gap of 2 megahertz. Let's just focus on this right now. So what if I set the integration bandwidth to lower than 30 kilohertz? For example, the signal that I'm transmitting is about 28 kilohertz. So let's say we set it to 10 kilohertz. So the reading is much lower than it should because I'm transmitting at minus 80 and the loss is just unacceptable. Chances are we are setting the IBW wrongly. So how do we check that? Because from the bar graph, you can't really see where's the signal, why our integration bandwidth versus the transmitter, whether it's correct or not. So let's click done for now, and let's change the display type to spectrum analysis mode. So how do we get there? Again, measure 1, display type, channel power. So as you can see, there's nothing on the screen because the signal is way below minus 90. Let's change the scale amplitude, reference level, something more reasonable. So this is where the signal happens, and definitely you can see that the integration, the dotted line here, is way smaller than it should. So in this channel power setup, the only thing that you can change is the integrations bandwidth, which is this. You can't change the resolution bandwidth manually or even the span manually. How do we change that? Let's go to BW. Integration, let's set it to something bigger. So instead of 28 kilohertz, let's set it to 30 kilohertz. So you can see the signal is well within that measurement part. So with this row off, we do take in the average of the whole channel power. That's why you are seeing a minus 80.5-ish, whereas when our transmitter is retransmitting at about 28 kilohertz. So let's change that. So it's a bit better. How about we set it to 20 kilohertz? No, it's a bit bigger, so it's 25 kilohertz. So let's try this again. Yeah, roughly that. Still have some power over here. Yeah, let's set it to 28 kilohertz. So this is where you're going to set and check whether the integration bandwidth that you are using is correct or not. Because like we saw just now, when we set the integration bandwidth right in the middle, we don't really cater for the whole channel power. So you're just taking some parts of the power and the reading is just not right. Again, before we go back to bar chart, this is where you can turn on the average so that the fluctuation will be lesser. Once you're happy with that, you can go back to display type, to bar chart, and do the data logging as you wish. So you might ask that, what if I have another channel? So let's say we turn on 2 channels. So done. So if you turn on the channel power right now, so this is channel 1. How do we change to channel 2? Is we go to frequency, change this to 2, and this is where 1.002 gigahertz. So there's nothing transmitted over here. That's why we don't get anything over here. Before we finish, one thing I want to mention also, you might want to turn on the preamp if you have the options to lower down further on the noise floor. So right now we are close to minus 130. So once you turn that on, you can get better noise floor and get a better signal to noise ratio. If your signal is quite high, it doesn't really matter, but if your signal is quite close to minus 130, if you turn on the preamp, and you should get a better reading, more accurate. Just to recap, in channel scanner, we can turn on the spectrum analysis mode just for a quick check to make sure that our integration bandwidth is set correctly, so that the power that we are measuring that display on the bar chart is correct. That's it for today. Thanks for watching.